Morning, everyone. I hope that you are all fine. I hope that you studied well this week. Now we are going to continue our lesson, okay, but in a new session, of course. So, as we said before that, our lesson is about forces, okay? Okay. Now we said that how do things move? We said that they move by forces. And we said that forces, what does it mean by force? Force is a power that helps us to move things. Also, we said that forces, they are two things. Either you push thing, you push it away from you, you push it against you, or you pull it to your side. Okay, so forces, they are push and pull. And of course, we took examples for this, push and pull. I will not repeat it again. And we said that push and pull, they are opposite forces. Why? Because push, you are pushing against you, and pull, you are pulling to your side. So both of them, they are opposite to each other. And I told you many times to take care that I'm talking about the force or I'm talking about the direction. Okay, the push and pull, they are opposite forces, but here, for example, in this example, he say that the box here is moving in one direction to the left side because each boy is pushing and pulling in one side, okay, but they are opposite forces, okay. Then we said that why push and pull, they are important because they make things start moving. If things, they are staying still or standing still, if I want to start moving them, so I must push or pull them. The second thing, if the things are moving and I want to stop them from moving, I must catch it or I must push it and pull it or must make anything in it. Okay, so this is the second importance. Third importance, that it changes the shape of things as the Play-Doh, as the dough of the pizza, the dough of the cake, the slime, anything. I'm changing the shape of things as push and pulling it in many directions. So it starts moving thing, it stops moving thing, it changes the shape of things. The fourth thing, it changes the direction of the things. If I want to move it to the right side, to the left side, up and down, if I want to change the direction of anything, I must either push it or pull it. Then the fifth thing, we said that it makes things slower as the shell of the snail or the shell of the turtle, they are pushing the animal down, they are making force on the animal, so they are making them slower. The last thing, why push and pull, they are important because they make things fast. Okay, and we said that there are two types of those forces. Okay, we finished the push and pull. Now there are two types, the balanced and the unbalanced force. What does it mean by balanced? Balanced is like the, in real life, the balance. When you say that something is equal to the other one, kilo oranges, it's equal to the oranges fruit itself. Kilo tomatoes, it's equal to the tomatoes, the fruit itself. So balanced force means that the forces, they are canceling each other. Why? Because they are equal, they are opposite to each other. As the pan of the kilos and the other pan of the fruit or the vegetable itself. Both of them, they have the same level. Both of them, they are equal. Okay, so balanced force means that they are canceling each other. They are equal. They are opposite to each other. So they are making a balanced force. The next thing is the unbalanced force. What does it mean by unbalanced force? That they are not equal, they are unfair, they are not canceling each other. Is the example that one is pulling from one side and the other, they are pulling from the other side. 1 to 4, is this fair? No. Is this equal? No. Are they canceling each other? No. So forces that do not cancel each other, forces that they are not equal to each other, they are called unbalanced, means that they are unfair. For example, if you got one pan and you put 1 kilo in them and you put a lot of potatoes in the other pan, this will be equal? No, they will not be equal, they will not be canceling each other. So one pan will be up, one pan will be down, so this is unbalanced. This is called unbalanced force. Okay, and then we took examples. I will not repeat them again, you have it with you. Okay, Now, today we are going to start a new thing. Okay, before we start, I'm sorry I skipped this part. That we said that the heavy objects, they need much more force than the light ones because they are heavy, so they need much more effort, they need much more power, they need much more force to move them, either to push them or pull them. Okay, now we will come to a new thing, which is our lesson today, and we will continue in the next weeks. Forces, they have three types. We finished the forces as push and pull, and we finished the forces as balanced and unbalanced. We have three types of forces. We are having three main things of forces: magnetism, friction, and gravity. In this week, we are going to study the magnetism. So don't be mixed up. In this week, I will talk only about the magnetism. Forget about those. I will talk in them in the next weeks. So today we are going to talk about the magnetism as a force. But before we start, what is a magnetism? This force? We must know that there is something called force meter. What does it mean by the force meter? Force meter, it is a tool that used to measure the forces. Let me give you an example. For example, if I told you, please measure me the length of the book, what are you gonna get? You will get a rubber to measure it. You're going to put it on the pen, on the balance. No, you are going to get just a ruler, just a measuring tape to measure to me the length of the book. And you will tell me, oh, Miss Mary, it is, for example, 50 centimeters. Okay, this is an example. The other example, for example, if I told you, please, I'm hot today, please, I want to know what is the temperature today. So what are you gonna get? You will get a thermometer for the weather, of course, not the thermometer we are putting it in our mouth. Okay, so you'll get the thermometer for the weather, and then you're going to tell me, oh, Miss Mary, today it's 30 degrees Celsius. So how did you measure the temperature? By a thermometer. How did you measure the length of the book? You measure it by a measuring tape or by a ruler. So how can you measure the forces? How can you measure the three forces? Okay, we are going to take, or any force, you're going to measure it by a tool which is called force meter. The force meter, as you see it here, it's just a tool and it has a hook at the end. Okay, and it has here the reading. This is much more clear, and this is the real one. Okay, so it has a hook in one end, and those are the readings, okay, with the grams and the kilograms. So you're going to put anything, and then you are going to tell me, oh, it's measuring whatever the thing, okay, or the weight he's saying to you. So again, what does it mean by a force meter? A force meter, it is the tool that it is used to measure the forces. Okay, now let us start the magnetism. Okay, magnetism is coming from the magnet. What does it mean by a magnet? The magnet is just a thing which is having two ends, this end and this end, the north end and the south end. Okay, but we are grown up and we are in science, so we are not going to say end. We must say it pole, as the poles of the earth. Exactly. We took before, or you took before, that the earth has the North Pole and the South Pole, right? What does it mean by pole? It means that the end, this is the end of the sport. So this is the south end and this is the north end. Exactly like the magnet. The magnet, it's a thing, it can have many shapes, by the way, so don't be mixed up. The magnet can be rectangle, the magnet can be U-turn shape, okay, it's making the U shape, okay, so it can be a bar like this, it can be the U shaped, okay, and it can be a circle, so don't be mixed up, it doesn't have one shape. So again, the magnet is just a thing that has many shapes, either the U shape, the bar shape, the circular shape, and it has two ends. And we are not going to say end because we are grown up and we are in science. It doesn't called end. It's called pole. It has the North Pole and it has the South Pole. Okay? So this is the magnet. This magnet, if you put it around things, it can attract, it can take it to it, and if you put it on another things, they can go away from it, it cannot attract it. Okay, but before we take this part, we're going to take it on Wednesday. We are going to take what happens when two magnets come together. If I put two magnets and they are having the same poles, okay, like the North Pole and the North Pole, they are going to be repelled. What does it mean by repelled? Repel means that they are going to go away from each other. They are not going to be attracted to each other. Again, if I put North Pole beside the North Pole or South Pole beside the South Pole, like poles, they repel. They are like each other, so they are not going to be attracted to each other. They will go away from each other. Again, year 3. If I'm getting two magnets, and the two magnets, we said that each magnet it's having two poles, the North Pole and the South Pole. If I'm getting two of those, if I'm getting two magnets together, if I put the North beside the North or South beside the South, they are mean that they are like each other. So like poles, they repel. What does it mean by repel? Repel means that they are getting away from each other. They will not be attracted to each other. Okay, so this meaning what happens to like poles, and this happens in real life when you get two magnets and then you start to push them together and then starting to attract together, you find that your hands is not cannot make it. You find that your hands, they are going away from each other. They have a very big power, and you cannot do it. Why? Because they are like poles. Either the north is getting to the north or the south is getting to the south. So they are repelling from each other. They are getting away from each other. Okay. The next case is that the north comes beside the south. North beside the south. So those are like? No, they are unlike. They are opposite to each other. This means that they are going to be attracted to each other. So again, class, or year 3, sorry, I'm sorry, year 3. Here, if you are having a magnet, we said that the magnet, it has two parts, the North Pole and the South Pole, north end and the south end. Okay, don't forget, but we are not going to say end anymore in size. We are saying North Pole and South Pole as like the Earth. If I'm getting two of this magnet, if I put the north beside the north, or I put the south beside the south, they are alike. They are the same as each other. So they are going to repel. They are going to be away from each other. But if I'm getting two magnets from those, and then I put the south beside the north, or here the north beside the south, they are going to be attracted to each other. They are going to become near to each other because they are opposite, they are unlike. Okay, I want you to see this video with me. Okay, he's talking about the magnet or the magnetism. Okay. see that the magnet, it has two poles. It has the North Pole and the South Pole, okay? Okay, I want to say something that we took or we saw together, the bar-shaped magnet. Now this is the U-shaped, as I told you, okay? This is the U-shaped magnet. It has also the two poles. I'm sorry. Okay, did you see here? They are different poles. They are opposite poles. They are unlike poles. The north is sticking to the south and the south is sticking to the north. Means that they will be attracted to each other. Why? Because they are unalike. Why? Because they are opposite to each other, so they will be attracted to each other. It took him a lot of effort to separate them. Why? Because they want to be stuck to each other. Okay, so take care. It goes away. Why? Because he was going to put the south beside the south or the north beside the north. So they became away from each other. They repelled from each other. Getting much effort to make them attract, and then they will repel at the end. Okay. So today we took them, before we start solving, today we took the magnetism. Okay, and we said that the magnetism, it's a kind of force, don't forget this. But before we took the magnetism, we took something called force meter. What does it mean by a force meter? Force meter is just a tool to measure the forces, as the ruler, as the measuring tape, as the thermometer. All of those, they are the tools. So the force meter, it's the tool that we use it to measure the forces. Then we started to talk about the magnetism. The magnetism, it's a kind of force. And we said that, what does it mean by a magnet? A magnet, it's just a piece. Either it's the bar-shaped or the U-shaped, or it has a circular shape. And we said that this magnet, it has two ends and two poles. Don't say ends anymore because we are scientific now. So we are saying two poles, the North Pole and the South Pole. What about if I put two North poles beside each other or two South poles beside each other? They are going to be like, they are going to be alike, they are going to be like each other, so they will repel, so they will be away from each other. What about if I put the North beside the South or the South beside the North? This means that they are unalike, they are opposite to each other. This means that they are going to be attracted to each other. Okay, now we will be coming to the last step in this session, that solving page 16 in your resource packs. Here he's saying to you, magnets, attraction and repulsion. We are going to complete question 1 using the words repel and attract. Okay, so here in this number 1, we're going to say that this is number 1, this is 2, this is 3. So number 1, here these magnets, they are going to do what in each other? Here is the south and north, here is the north and south. What is here? The north is beside the north. Are they alike or opposite? Yes, they are alike. So are they gonna be repelled or attracted? They will be repelling each other. Excellent ones. Number 2, here are another 2 magnets. He's putting the first the north and then south and then south and then north. So also he's putting the south beside the south. Are they alike or opposite? Yes, they are alike. So they are going also to repel each other because they will be away from each other. The third example, he is putting 2 magnets, south north, south north. Here is the ones which are beside each other is north and south. Are they alike or are they opposite? They are opposite to each other, so they are going to attract each other. Don't forget that alike poles or like poles repel, either the north beside north or south beside south, they are going to repel. They're going to be away from each other, or the poles which they are opposite to each other, the north beside the south or south beside the north, they are going to be attracted to each other. Okay, now we will come to question number 2. He's saying to you, which poles of the 2 magnets attract each other? Yes, they will be the south and north or north and south. Both of them, they are correct. Now question 3, which poles of the 2 magnets repel each other? Yes, it will be the south and south or north and north. If I put the south and south beside each other or north and north beside each other, they are going to repel. Now the last question, question 4. What happens when 2 like poles, the same poles, they are placed together? They are going to be excellent. They will be repelled or they will repel. I hope that you understood this part very well. Don't worry that I said in each session I will be repeating every part we studied before or we explained it before. I hope that you got all of the info today. I will repeat them the next session. Don't worry if you missed the part. Okay, and then we will continue our new lessons in the other times. Thank you so much. I hope that you will study well.